Okay, so right hand rule number 3 is going to tell us the direction of the force that a charged particle will feel if it moves into a magnetic field. So magnetic fields are capable of applying forces on charged particles, electrically charged particles. And that's a big thing. That we used to think that magnets can only apply forces on magnets, but now we understand that magnets can apply forces on charged particles that are moving. Right-hand rule 3 gives the direction that this force is going to be. So we have our index finger in the direction of the velocity of the particle, the middle finger in the direction of the magnetic field, and then your thumb has to stick out at a 90-degree angle to both of your other two fingers. That'll be the direction of the force. Now recall, if you read the notes, the direction of the velocity. The direction of the velocity is assuming it's a positive charge moving that way. If it's a negative charge, we actually have to use the opposite direction, which will be the second example here. All right, so the first example, the one on the left, we've got a horseshoe magnet, and then we've got a positive charge moving through it. That Q plus means that that's a positively charged object. So my index finger is going to be to the left. That arrow to the left represents the velocity. And my middle finger needs to be in the direction of the magnetic field, which I have to kind of figure out based on the horseshoe magnet. So if I were to stick a compass in between this horseshoe magnet, which would the compass point? It would actually point upwards because it would repel from the north, it would attract to the south. So the magnetic field, which I'm labeling in blue here, is actually up, and that's the way your middle finger has to point. And then you ask yourself, which way does my thumb point when I do that? So I'm going to set my pencil down. I'm going to take my right hand, get my three fingers all in 90 degrees to each other, make it so that my index finger is pointing to the left of the page, and then twist my wrist, rotate my wrist until my middle finger is pointing up in the direction of the magnetic field. You may find that twisting your wrist is easier sometimes, or that actually picking up your piece of paper, or I guess in this case your Chromebook, picking it up and moving that around might make it easier on your wrist. But either way, you need to have your index finger pointing to the left and the middle finger pointing up. And then I will find that my thumb is pointing into the page. And my thumb ends up pointing into the page, which is denoted with by a circle with an X. Okay, so this particle will feel a force into the page. Now, this will only be for a moment, because once it feels a force, that force will make it curve. It's going to make this curve. Just like how gravity makes projectiles curve, these magnetic fields will make charged particles curve. It will not be a parabola, though. It will be something else, which is for lesson 3. But at this specific instant in time where this picture is drawn, the force on the particle will be into the page. How about the other one? Okay, the other one has a couple of differences. One big difference is that the charge is negative, meaning that when I point my index finger in the direction of the velocity of the charge, since it's a negative charge, I actually have to point it in the opposite direction. So I'm going to have to point this, I'm going to call this down and to the left. Well, I'll just draw the arrow. My index finger needs to point down and to the left, or the opposite direction of the velocity of the charge. My middle finger has to point in the direction of the magnetic field, which is into the page. So you're going to have to do some wrist twisting to get that to work. And then your thumb, just make sure your thumb is sticking out at a 90-degree angle to both of your other two fingers. So set my pencil down. I'm gonna get my right hand and wrist twisting. And when I have it set up, when I've got the green and the blue fingers set up properly, I find that my thumb ends up pointing bottom right, down into the right. Okay, so the particle will feel a force this way. Once again, that's going to cause this particle to curve. So it's going up into the right, but it feels a force down into the right. So that force is going to cause the particle to change directions. It's going to start curving.